So today we're talking a little bit more about division. So today we're continuing to talk about division, and we're specifically talking about estimation in division. So note that estimates are not exact answers. They're close to exact answers. So we want to get close enough so that we can tell what the exact answer will be, but not necessarily the exact answer. So the closer an estimate is to the exact answer, the better an estimate it actually is. So let's look at this one. If we have 160 divided by 20, we could make that into an easier division question, right? If we divide both of these by 10, we'd end up with 16 divided by 2, which makes it much easier because we know 16 divided by 2 is 8. So if we did 160 divided by 20, that would actually be 8 as well. Because we divided both the dividend and the divisor by the same number, we divided both of them by 10, our answer for this one will be the same as the answer for this one. So they said cutting a 0 from all the numbers. I don't like referring to that because then it makes it sound like we can just cut zeros off of numbers anytime, and that's not true. But if we cut a 0 off from both of these, it's the same as dividing them all by 10. And if we cut 2 zeros off of a number, it's the same as dividing it by 100. So I don't like using this terminology, cutting zeros off, because it makes it sound like you can just cut zeros off without any regard to what happens after that. And that's not true. You have to understand what you're doing when you're cutting those numbers off. That's why I like referring to dividing them by 10 or by 100. So if we had this one, 2,840 divided by 20, now since we have zeros on the end of both of these, we can divide both of them by 10 and make that into 284 divided by 20. Or, sorry, divided by 2, not by 20. We took that 0 off by dividing by 10. So this is a little bit more confusing, but we can easily do it when we look at number by number. If we take the 2 divided by 2, it would be 1. 8 divided by 2 would be 4. And 4 divided by 2 would be 2. So the answer would be 142. In this one, we can do the same thing, but now look, here's why I don't want to just talk about cutting off zeros, because some students would be tempted to say, oh, I can cut off these 2 zeros and this 1 0. And that's not the way it works. We cannot do that. You have to understand that you can only take off as many zeros in the dividend as you have in the divisor. So we're going to divide by 10, taking off this 0 to make it 60 divided by 2. That is a division sign there. And 60 divided by 2 will be 30. And the same thing here. Even though we have 2 zeros up here, we can only take one of them off because we can only take one off here. We can only divide it by 10. So this gives us 80 divided by 4, which will be 20. And looking at these ones, a similar thing. We've got a 0 here and a 0 here. So we can divide both the dividend and the divisor by 10, giving us 36 divided by 9, which will equal 4. And here, dividing the dividend and the divisor by 10, we end up with 42 divided by 7, which will equal 6. So that's just a way to make our division a little bit easier so that it's not quite as complicated. And when we do, and the reason why we're introducing this first is because this is related to our estimation. So now here, if we want to estimate this, notice these squiggly equal marks. When you see these squiggly equal marks, you know that they mean approximately equal to. The straight ones mean that it's exactly equal to, it's exactly the same, but the squiggly ones mean approximately, almost equal to. So if we want to find out what this would approximately be, if we want to estimate this, then we would need to round the numbers. This is why we needed to learn how to round numbers before we can do estimation. So we could round this to the nearest 10. So we would leave the hundreds by itself. Rounding it to the nearest 10, we look at the number that's behind it. Since it's close to 10, we would round the 1 up to 2 in the tens place and a 0 in the ones place. If we round this to the nearest 10, we should round this one to the nearest 10 as well. So looking at what's in the tens place and what's beside it, to the right we have a 9, which means we round it up. So we're going to do 820 divided by 20. Now we can use the exactly equal sign because we are doing the exact division for this one. Now look again. Since we estimated, now we have zeros in the ones place. So we can divide by 10 for the dividend and the divisor to get 82 divided by 2. And again, we're going to find the exact answer for this. Divide the tens. 8 divided by 2 will be 4. Divide the ones. 2 divided by 2 will be 1. So we can say 817 divided by 19 is approximately 41. It won't be exactly 41, but it will be approximately that. Okay, and this is just what we worked through up there. Oh, I know, we needed to do this one a little bit differently. That one was rounding to the nearest tens. And this time we're going to do what we call, you notice down here there's words that say front-end estimation. Front-end estimation means that we look at just the first number of each of the first digit, I should say, of each of the numbers, and round to that digit, whether it's in the hundreds or the tens. So this one, from the hundreds, the tens is a 1, so this would stay at 800. But for this one, in the tens we have a 1, and in the ones we have a 9. So we would round it up. So 800 divided by 20, and again we would use the equal sign, not the approximately equal, because we're doing the exact division. And again, we can take off the tens if we want, divide by 10 I mean, to do 80 divided by 20, and that will give us 40. So 817 divided by 19 is approximately 40. Now, because we rounded this up, we're going to get a different number than what they're showing us on the next slide. A different way to do front-end estimation, and it's the way that I don't like as much, is to start out with 819 divided by 17, divided by 19, and just ignore these numbers that come after the leading digit. So then we would say 800 divided by 10, which would be the same as 80 divided by 1, which would give us 80. So this is how front-end estimation can give us an estimate that sometimes is wildly different. Because when we rounded to the nearest 10, we got 41, but our front-end estimation got us 80. Let's find out what the actual answer is and see what it should be. 819 divided by 817, I keep putting 19, divided by 19. I'm going to actually use my calculator to figure this one out. The actual answer is 43. So which method gives us a better result? Obviously, rounding to the nearest 10 is more precise, and so it gives us the better result for this one. Okay, so we call these numbers compatible numbers. Okay, here we go, starting at the top. Another estimation strategy uses numbers that are close to the actual numbers, but easier to calculate. And we call them compatible numbers. And then to do the calculation mentally, we often use multiples of 10. So for example, if we had 187 divided by 6, how could we estimate that to be close? What multiple of 10 is close to 187 and divisible by 6? If you said 180, then you'd be right. 180 divided by 6 is fairly easy to do, right? Because we know that 3 times 6 is 18. So we could say 180 divided by 6 would be 30. And that's how we can use compatible numbers to estimate our division. Just 3 different ways to do it. Here's another example. If Marcel has asked some friends to help him sell tickets to the school play, he wants to divide 417 tickets as evenly as possible among 7 people so they can each sell some. About how many tickets does each person get? Well, this is one way to estimate. We could say if we have 7 times 10, if we gave each person 10 tickets, then that would be 70. 7 times 2 would be 140. 7 times 3, 210. 7 times 4, 280. 7 times 5, 350. See how we're getting closer to 417? 7 times 6, 420. 7 times 7, 490. 7 times 8, 560. And 7 times 9, 630. So about how many tickets does each person get? Which number is closest to 417? We've got it right here, right? 420 is close. So 7 times 60 would be 420. So each person would get about 60 tickets. So that would be close. So we could do that with these as well. If we start with 6, we could make a table like this and say, okay, if we want to times 6, 6 times 10, 20, 30, 40, 50, and 60. And about what would that be? 6 times 10 would be 60. 6 times 20 would be 120. 6 times 30 would be 180. 6 times 4 would be 240. 6 times 5 would be 300. 6 times 6 would be 360. We're getting close, right? 360 is pretty close to 379. Let's do one more, see if we can get closer. 6 times 70 would be 420. So which number would you say is the closest to 379? It would be 360, right? So right here, we could say 376 divided by 6 is approximately 60. It won't be exact, but it's approximate. And we can use this to find if our answers are reasonable. If we have 214 divided by 3, is it reasonable that the answer is 76? Well, let's see. If we multiply 3 times 10, let's do this, times 3, 10, 20, 30, 40, 50, 60, and 17. We would go up to 70 because we have 76 here. And we want to know if the answer should be close to 70 or not. 3 times 10 would be 30. 3 times 20 would be 60. 3 times 30 is 90. 3 times 40, 120. 3 times 50, 150. 3 times 6, 180. 3 times 7, 210. So is 210 close to 214? We've got our 3 here and our 70 here. It is close, isn't it? Notice how the answer here, 76, is a little bit more than 70. And the number that we got here and here, this number 214 is a little bit more than 210. So because they're both a little bit more, then we can say that our answer is reasonable. Oops. Didn't have this one up ready to go. All right, so we're going to switch and do a little bit of long division now. Some students get really caught up with long division and find it really tricky. As long as you keep the steps straight, you should be just fine. So another symbol for this, for the division symbol, is this frame that we can use. So 10 divided by 2 can be written as 10 divided by 2. Notice that our dividend always goes inside. I always refer to this as a house. The dividend goes inside. The divisor goes at the front door. And then down here you can see that the quotient goes on the roof. Just kind of a funny way to remember that. The dividend goes inside. Divisor goes at the front door. And the quotient on the roof. All right, so looking at this one, if we want to express this statement or the equation, because it has an equal sign, so it's an equation, and in the new notation, that just means using this frame. So we would say 14 divided by 3 gives us 4 with a remainder of 2. That's all they're asking us to do here. Again, write the frame first, or the house. 26 divided by 7 is 3 with a remainder of 5. And down here again, house first. 819 divided by 4 gives us 204 with a remainder of 3. Now I'm going to point something else out here. Sorry, wrong thing. I want to draw, I'm going to change colors for a minute. I change to red. And I want to point out how I lined these up. Right here, and right here. Make sure when you're doing your division, when you're using this frame or the house, that you line up your division properly. So for this one, for example, if I did 14 divided by 3 is 4, remainder 2, like this, really what I'm saying then is that 1 divided by 3 equals 4. And we know that's not true. 1 divided by 3 is definitely not 4. But when it's lined up this way, we're saying 14 divided by 3 equals 4. Make sure that your numbers line up down here. We're saying 8 divided by 4 equals 2. 1 divided by 4 is 0. And 9 divided by 4 is 4. And we've got the remainders in these ones, just to make it confusing. But just make sure that you've got them lined up correctly. That's my point in this. Something added that they didn't say, but I wanted to point it out to you. So here, if we have, we're going to work through this division question together. If we have 72 divided by 3, think of it, sometimes it helps to think of it as a story problem or as a word problem. So here we've got 3 friends wish to share 7 tens and 2 ones as equally as possible. Maybe it's 72 candy canes that they want to give out to their friends. Maybe it's 72 cookies. It's obviously getting towards lunch because I can only think of food to be sharing. Maybe it's 72 pencils. I don't know. But 72 things that they want to share. So we could draw a picture or draw out the tens to show how we would divide this. Just going to expand it a little bit more. So this is the same one that we had before, 72 divided by 3. And here we have our 7 tens. 1, 2, 3, 4, 5, 6, 7 tens, 2 ones, and we're going to divide them by 3. So if we put a group of 3, we can move these around. Let me see if I can move these separately. I can't move these. Well, maybe I can. Hang on. Yep. I can move these separately, so let's do this. We're going to move a 10 over here to be in one group. Another 10 we're going to put here. And another 10 here. So we've got 3 tens that are split up. But we still have more 10s, right? So let's put these 10s with the other 10s. Now we have 2 10s in one group. 2 10s in another group. And 2 10s in a third group. But now we have a problem because we have a 10, a 1, and a 1 left over. And that's not going to work, is it? Look at how we're going to put this notation. We've got 3 groups. 1, 2, 3. And we've got 2 sets of 10 in each one. So we're going to put the 2 up here. Sorry. Because we were dividing 10s, right? And the 7 is in the 10s place. Now, how many 10s did we put into groups? 3 groups with 2 10s in them gives us 60 10s. So we've taken out 60 10s and put them into groups already. So we're going to subtract those out, leaving us with 1 10 and 2 1s. And that's what we have over here, right? 1 10 and 2 1s. Let me just see what... Yeah. They're confusing us with trying to give us other things to do here, but we're going to go back to this. Okay, so this is the exact same thing that we just did, right? You got the two groups of 10s, 3 groups with 2 10s in each, right? We subtracted it out. I don't know why this isn't going to the slide that I want here. There we go. So this is like what I had up there, right? We've got 1 10 left over, but we still have those 2 1s. I'm just going to go back up here because I feel like they're making it more confusing than it needs to be. So we've still got 12 things here to divide by 3. We can't just leave them alone. We can't just say, oh, we're just going to share 2 groups of 10. That doesn't work. I'm going to switch colors to show our next steps that we're doing. So now we have 12 things, but we can split this 10 up into ones, right? So now instead of having 10, we can say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can put those things into groups of 3. Let's try putting them into groups of 4. So there's one group of 4. There's another group of 4. And with 2 here, and we still have these 2 1s down here, we've got all of these. There's another group of 4. So we have 3 groups of 4. So we can put that up here above the 2 because we're showing that we have 12 things divided by 3 is 4. 3 times 4, so we're taking out the 3 groups of 4, will be 12, and we have 0 left over. Okay? So just to recap, here are the steps that we do. First we divide. We did 70 divided by 3. Then we multiply. 3 times 2 gives us the 6. And then subtract. Take out that 6 to show that we have 110 left over. And then bring down the 2. So if we had another number over here, we'd bring down the next number down to here. And sometimes we show that with an arrow. But sometimes we can just put that placeholder 0 in there to help us to make it make sense. Okay? And then look what we did in this part here. We started over again. We divided the 12 things that we had right here by 3, right? So we started back with divide. Then we multiplied the 3 times 4 to get this 12. We subtracted 12 minus 12. And then there was nothing left to bring down, so that's how we knew that we were done. Okay, so those are the steps to doing long multiplication. I'm just going to skip through all of these because they make it a little bit confusing with all of their pictures. Here it's just showing that we have 24, right? Because we put the 4 up here. And that's the answer that we got, right? From the exact same question that we did. Now, one last thing before we go. You can check your answers with multiplication. So if the long division gives you 69 divided by 4 equals 17 with a remainder of 1, we can use multiplication to check. Remember that multiplication is the opposite operation of division. So if we take the 4 and the 17 and multiply them together, This is why we had to learn multiplication before division, because you need to use multiplication to do division. 4 times 7 is 28. 4 times 1 is 4, plus 2 more is 6. We got 68, but wait. Here it's 68, but we have 69. What did we miss? Our remainder, yeah. We have to add the remainder in. We have to add 68 plus 1 to give us that 69. And then we know we've got the right answer. Always remember at the end to add your remainder so that you end up with the right answer at the end. All right, so that is it. That's all that I was going to go over today in our class. So I hope that helps and that you understand division a little bit more. If you need any help with it, then let me know, and I can definitely schedule another session to help you with it. Talk to you later.